Next topic is carboxylic acids. What are carboxylic acids? These are the organic compounds in which COOH group is present. COOH. This is the functional group. And for IUPAC name, for this we add suffix oic acid. Example, if it is CH3COOH, there are two carbons, so eth for single bonds between carbons, ane, and then for carboxylic group it is oic acid, so it is ethanoic acid. And the common name for CH3COOH is acetic acid, which is also present in vinegar, which we use in our kitchen. And then if HCOH, it has only one carbon, so it is meth. Then for single bond, ane, functional group is COOH, oic acid, so it is methanoic acid. And common name is formic acid. So these are the IUPAC names: ethanoic acid, methanoic acid. Similarly for this, CH3, CHCOH, CH2, CH3. For this we already know that functional group is given preference, so COOH will be given number 1, then 2, 3, 4. So this is the carbon chain, that is 4 carbons are present, so it is but, single bonds, ane, and then this is the side group attached, so it is attached at the second carbon, so it is 2-methyl 4 carbons butanoic acid. So we can write IUPAC name by using suffix COOH. Similarly, if we take up another example, that is CH3CH, COH, CH2, CH2, COH, that is, and this compound 2 COH groups are present, and these two groups are present at different carbons, so we have to first number the carbons. So, and number is suppose 1, 2, 3, 4, 5, and this methyl group is at second position, so it is 2-methyl, then 5 carbons are present in a chain, so single bonds, ane, and then 1,5-dioic acid, because 1 at 1 it is present COH group, then it is at the 5th carbon, so 1,5-dioic acid, 2-methyl pentanoic acid. And then if we take up another example, CH2COH, CH2COH, in this there are 4 carbons, so but, single bonds, ane, and then 1 and 4th carbon has carboxylic group, so butane 1,4-dioic acid. So next is the methods of preparation of carboxylic acids. These methods of preparation are the repetitions of the reactions we have already done in the previous chapters, that is in alcohols and then in aldehyde ketones. So first is from oxidation of alcohols. This we have already done in detail in alcohol chapter. Then from oxidation of aldehydes and ketones, from hydrolysis of nitriles, from Grignard reagents with carbon dioxide, from acid chlorides and acid anhydrides, from esters, from alkyl benzene, from methyl ketones. So there are a number of methods from which carboxylic acids can be prepared. So first is from oxidation of alcohols. In this we already know primary alcohols always give carboxylic acid with same number of carbon atoms. That is, first they give aldehydes with same number of carbon atoms, then upon further oxidation gives carboxylic group with same number of carbon atoms. And then in secondary alcohols, we upon oxidation ketones are formed with same number of carbon atoms, and then further oxidation gives carboxylic acid with less number of carbon atoms, And in tertiary alcohols, first ketones are formed with less number of carbon atoms due to carbon-carbon bond cleavage, and then upon further oxidation gives carboxylic group with still less number of carbon atoms. So this is how we get carboxylic acids from alcohols, which we have done earlier also. Now example is convert butane 1-ol to butanoic acid. This is butanol and this is butanoic acid. That is, this is a primary alcohol. OH group is attached to the carbon which is attached to one other carbon. So it is a primary alcohol. Primary alcohol will give carboxylic acid with same number of carbon atoms. So carboxylic acid with same number of carbon atoms. Now for oxidation, we have already done also. There are a number of reagents which can be used. Potassium dichromate in acidic medium, or KMnO4 in basic medium, or concentrated nitric acid can also be used. Similarly, if we want to convert benzyl alcohol to benzoic acid, this is benzyl alcohol. This is again a primary alcohol. So carboxylic acid with same number of carbon atoms. So upon oxidation with potassium dichromate in acidic medium gives benzoic acid. We can also use Jones reagent, that is chromium oxide in sulfuric acid in aqueous solution is called Jones reagent, and it is also used in oxidation for alcohols. And then is by the oxidation of aldehydes and ketones. This also we have done. In this, aldehydes can be oxidized by Tollens reagent, Fehling solution, then Benedict solution, and ketones can be oxidized by MPV reduction, that is Meerwein-Pondorf-Verley reduction. This we have also done in detail in previous chapter. Then next is from hydrolysis of nitriles. Nitriles means CN, and hydrolysis of nitriles in acidic or basic medium gives acid amides, and then upon hydrolysis gives carboxylic acid and ammonia. That is, from here the bond cleavage takes place and we get OH group gets attached to this and H to this, so ammonia and carboxylic acid. And if we take a particular example, that is, this is a nitrile with 2 carbons, so it is ethane nitrile. When with water in the acidic or basic medium gives ethanamide, upon further hydrolysis gives ethanoic acid. And similarly we can say that ethane nitrile to ethanoic acid is converted here in this particular example, and then we can convert benzonitrile to benzoic acid also. This is CN group attached to benzene ring, then it gives acetamide, and then it gives carboxylic group, that is benzoic acid. The next method is from Grignard reagents, that is with carbon dioxide. In this alkyl group will get attached to this carbon, and this MgX will be attached to this oxygen, that is OMgX, and R gets attached to this carbon in the presence of dry ether to give this, and this upon hydrolysis gives, here the bond cleavage takes place, then out of water H gets attached to this oxygen and OH gets attached to this MgX. MgX OH is present here. So it is basic magnesium halide is formed as a side product. So this is with Grignard reagent with carbon dioxide gives carboxylic acid as a final product. And similarly, if we take an example, that is instead of R we use ethyl, then with carbon dioxide in the presence of dry ether we get first this product, and this upon hydrolysis gives this acid CH3CH2COOH, CH3CH2COOH, that is propanoic acid, and here again Mg Br, and here is OH. So this basic magnesium bromide is formed. And so next is from acid chlorides and acid anhydrides by hydrolysis. These acid chlorides with water in basic medium gives carboxylic acids and HCl. That is, from here bond cleavage takes place and we get RCOOH. Cl is replaced with OH. This is this. So carboxylic acids are formed. And similarly, if we take an example of 2 carbon, that is ethynyl chloride with water in the presence of OH negative gives CH3COOH, CH3COOH, and with plus HCl. So this is CH3COOH, ethanoic acid is formed. And similarly, if we treat acetic anhydride with water, again we get, there are 2 RCO groups, so 2 carboxylic acids, RCOOH, RCOH. And similarly, if we take a particular example, that is acetic anhydride is taken or ethanoic anhydride is taken, then we get 2 molecules of acetic acid, ethanoic acid, or say ethanoic acid. And similarly, if we can also prepare carboxylic acids from hydrolysis of esters, that is esters with water in the presence of acidic or basic medium gives carboxylic acids plus alcohol. In this is shown, that is water combines like this. From here bond cleavage takes place and H gets attached to O and OH gets attached to R, so carboxylic acid and alcohol is formed. Similarly, if we take example ethyl ethanoate CH3COO C2H5, here again we will get CH3COOH, ethanoic acid, plus alcohol, that is ethanol. And next is from alkyl benzene. Alkyl benzene upon alkaline or acidified KMnO4 oxidation gives COH group, that is alkyl group gets converted into COH group, whether it is methyl, ethyl, or any alkyl group. So CH3 gives COH. Similarly, if there are 2 CH3 groups attached to a benzene ring, then both are converted into COH groups, both are oxidized to COOH groups. So next is, if we have to convert toluene to benzoic acid, that is we can easily do, that is 1 CH3 groups attached, that is same this reaction. This is the toluene to benzoic acid. So next is convert propyl benzene to benzoic acid. This is propyl benzene, propyl group is attached to the benzene. So we already know this, if there are 1 carbon, 2 carbon, or 3 carbon, all gets oxidized to COH. So COH is formed with first KMnO4 gives potassium salt of acid, then upon hydrolysis gives benzoic acid as a final product. So next is from methyl ketones, and this reaction is called haloform reaction. This also we have done in previous lectures. So next is, if we have to convert 4-methyl acetophenone to benzene 1,4-dicarboxylic acid, 4-methyl acetophenone, that is COCH3 group is attached, it is aceto group, and to the 4th position methyl, so it is 4-methyl acetophenone, and it has to give 2 COH groups, it will be converted to COH group. And for this, first we have to convert it into potassium salt with KMnO4 in basic medium, it gives potassium salt of acid. Then upon further hydrolysis, this will be converted into COH, and this will be converted to COH in the first step, oxidized to COH. So we can easily get carboxylic group with oxidizing agents. So next, in the next lecture, we will start with properties, and that first physical properties and then the chemical properties. So till now we have done different methods of preparation of carboxylic acids from the various organic compounds, which are just the repetitions of the previous reactions. So it's all about the methods of preparations of carboxylic acids. So thank you.